Hi, and welcome to the video on writing the standard form equation from the graph of a polynomial when there's a greatest common factor. So before we begin in the notes, I want to just summarize what we've already learned and have done in class. If you're given the graph of a polynomial, you can write its standard form equation by following these few steps. The first step is to identify the roots of the polynomial, and that's where the graph or the plot crosses the x-axis, and we have two roots here, one at x equals -3 and one at x equals +2. We can then use the roots to write the factored form equation, but the one thing we must remember is that for our factors, we have to flip the sign of the roots. So the first root is x minus 3, that's going to give us the factor of x plus 3, and the second root is x equals 2, and that's going to give us a factor of x minus 2. Again, we just flip our signs. Once we have the factored form, we can multiply our factors using the box method. So we set up our boxes, and our first factor, x plus 3, we can write along the top. Second factor, we can write along the side. And then we just multiply top and side of each box. So x times x will give me x squared, and so on. Once we have that all multiplied out, the next thing we can do is we just combine like terms, and when we do that, that's going to give us the standard form equation once we set it equal to f of x. So for this example, we get f of x equals x squared plus x minus 6. This equation matches our graph here. So now let's talk about greatest common factor. We're now going to look at cases where there is a greatest common factor, and this is from just the Math is Fun website. The greatest common factor is the highest number that divides exactly into two or more numbers. So let's take a look at an example where there is a greatest common factor. If you have the expression f of x equals -2x squared plus 2x plus 6, what you notice is that each of these terms can be divided by this -2. Or another way of looking at it is that -2 has been distributed to all the terms in this factor. And so as a result, for all of these terms, there is a -2, which is a factor of it. So we're going to now take notes. Turn to page 11 of your packet. There is a map there that you're going to fill in. And this is the Unit 1 Multiplying Polynomials Lessons 3, Part 2 packet. All right, so this is the section of the page that you want to be on. And I'm going to walk us through the steps for how we do it. As I display information on the screen, I want you to write that information on your paper. Pause the video as necessary. Okay, so we're starting with the graph, and the first few steps are going to be the same. As in the previous example, we're going to use the roots of our graph to get a factored form. So here we have roots at x equals -1 and x equals +3, and I just listed those roots. The next step is to use those roots, as I said, to write the factored form, and again we're going to flip the sign. So for the root x minus 1, that's going to give us a factor of x plus 1, and for the root x equals 3, that's going to give us a factor of x minus 3. One thing that has changed though, however, this is a draft of the factored form equation. So what we're going to do in addition to writing down our factors is put in this a, which is our greatest common factor, and we're multiplying a with all of these other factors, right? So we just write it right next to the factors. And now we need to go ahead and find a. Now this next step has multiple steps. The very first step within this step is to pick a point on the graph. Okay, and again, when I say graph, I mean this plot here. But there are two caveats. It cannot be a root or a decimal. So let's take, for example, I could choose the point 2 comma 6. It's not a root, it's not a decimal point. That point is on 2 grid lines, so I can use that. I could not choose 3 comma 0, which is one of my roots, or I could not choose a point here, which is around 2.7 comma 2, because I'd have to estimate the x value. So we're not going to use those points. Take a moment and look at the graph and see if you can identify any other points on the graph that you can use. Pause the video, and then when you press play again, I'll show you the points. All right, so you may have identified these 2 points here, one at the vertex, which is 1 comma 8, and then the other one, which is the y-intercept, 0 comma 6. You can use any of these points in our next step, but we're going to just use the point we started off with, 2 comma 6. And the next step is to plug in the x and y, and we're going to plug that into the factored form equation. So remember, f of x, all of f of x is y. So I'm going to replace this whole left side of the equal sign, this whole f of x, with our y value for that point, which is 6. And all of the x's I'm going to replace with 2. So now I get this expression, 6 equals a times 2 plus 1 times 2 minus 3. Great. Now we can go ahead and solve for a. And that's simple. We're just going to follow order of operations. So we're going to do what's in the parentheses first. And when I combine the terms inside the parentheses, 2 plus 1 will give me 3, and 2 minus 3 will give me negative 1. Once my parentheses are done, I can go ahead and move on to the multiplication. I can multiply the 3 and negative 1, which will give me 6 is equal to a times negative 3. Notice how everything else just comes straight down. And now I can go ahead and solve for a by dividing both sides by negative 3. I'm isolating my a there. And when I do that, I get that a is equal to negative 2. All right, so once I have a, I can go on to the next step, which is to write the factored form, the final version of the factored form. And I do that by simply plugging a into my draft form. So here's my draft form, and I'm just going to plug in negative 2, the value I got for a, right into the draft. And now this is my final factored form, and I can use that to get the standard form. We're going to get the standard form the same way we did it before. So the way that we did it before was we multiplied using the box method. And I like to multiply my binomials first, and then once I've done that, I will distribute my a back in, especially when I'm dealing with fractions, when a is a fraction. So let's go ahead and multiply x plus 1 and x minus 3 using our box method. And we do that, we get x squared, x, negative 3x, and negative 3. Now we can go ahead and combine like terms, and I get f of x equals x squared minus 2x minus 3. But now I have to remember that I need to multiply this product, which is the product of these two factors, with negative 2. So I'm going to put that right back in there. And now I just distribute my negative 2 to all of my terms there. And then I get f of x equals negative 2x squared plus 4x plus 6. So this is the process, and that's my standard form equation. One thing to note about this process, the reason why it works, the reason why we can pick a point, which was one of the things you gained from the lesson last time we were together, is that since if this graph matches the equation that we have, any value that we find in the graph, we should also find in the equation, meaning that if I plug in a certain x coordinate into the equation, I should be able to get the y coordinate of that point. Okay. So let's just summarize our process here. Process starts the same as before. Use the roots to find the factor form, but this is a draft of the factor form, and we have to remember that we have to include the a, which is our greatest common factor, which is what we'll be finding next. To find it, we pick a point from the graph. those points cannot be the roots or decimals. Any other point works. We plug in the x and y. One thing to remember is that when we plug in our y, we're going to replace all of f of x, because f of x is y. So we're going to replace f of x with our y coordinate and all of the x's in our factored form graph with the x coordinate. We solve for the greatest common factor, which is a. Once we have our value for a, we're going to plug a back into the factored form graph to get the final factored form. And then we multiply our factors form to get the standard form equation. All right. On page 7, I want you to try questions 1A and 1B. And then on page 8, I want you to try question 2A. And you can check your answers to these questions just to see how you're doing. And then you continue on with the practice, which depending on where you left off, you may just have pages 7 through 11 to do. All right, hope you found this video helpful. I'll see you all next time. Have a great weekend.